In examples 1 through 5, we want to find the first partial derivative of the given function, first with respect to x and then with respect to y. We're mixing in different notations throughout the problems just to keep ourselves familiar with those different ways of asking for that, but every problem is asking for the same thing. We'll start off in example 1 by finding delta p over delta x. That means when we differentiate, we're only differentiating x as a variable and y we're just treating as a constant. Meaning we could essentially set minus y aside and then we're differentiating x because that delta x notation tells us to differentiate with respect to x. This would give us negative y because the derivative of x would just be 1. Now if we find delta p over delta y, we'll end up with a different result. Here we're treating y as the variable and x just as a constant. So we would take negative x times the derivative of y, which would just give us negative x, since the derivative of y would be 1. In example 2, we want to find delta over delta x of r of xy. That means we'll take negative 4 e to the x minus 2y, since the derivative of an exponential is just that exact same function, then multiplied by the derivative of that interior expression. But keep in mind, we're only differentiating with respect to x. So this will become negative 4 e to the x minus 2y times 1 minus 0. Because 2 times y we just treat as constants, so that derivative goes to 0. And our result will be negative 4 e to the x minus 2y. Now, to take the partial derivative with respect to y, we start off the same since we're still differentiating an exponential function with the chain rule. But when we differentiate that interior function, now we're differentiating with respect to y, which will give us negative 4 e to the x minus 2y times 0, since we're treating x as a constant, and the derivative of negative 2y will just be minus 2, negative 2. So we'll get negative 4 times negative 2, or 8 e to the x minus 2y. It's very clear from the first two examples whether we're differentiating with respect to x or differentiating with respect to y, we end up with different results. So again, we need to pay close attention to what we're being asked to find in each case. In example 3, we want to find t sub x, which means differentiate with respect to x. And that means 2y to the fourth will just be treated like a constant or a coefficient. And then we'll take the derivative of x squared plus 2 times the derivative of x squared. This will give us the derivative of x squared will be 2x, so we'll end up with 4y to the fourth times x plus the derivative of x squared will be 2x, so we end up with plus 4x. Then to differentiate with respect to y, 2x squared is just treated as a coefficient or a constant multiple. And then we'll take the derivative of y to the fourth plus the derivative of 2x squared differentiated with respect to y will give us 2x squared times 4y cubed plus 0, since there's no y in that second term. And we get 8x squared, y cubed is that first derivative.